All right, here we go. Question number 9 from our 1316 homework number 2 in MyLab Math. Graph the following function. Show at least 2 cycles. Use the graph to determine the domain and range of the function. So here we have a cosecant function. And so I'm going to start by recopying the equation over here on the side. And the first thing I guess I want to say is that to graph a secant or a cosecant means that you're going to follow the 6-step method for graphing a sine or cosine. And at the very last step, things change, okay? But to graph a secant or cosecant follows the exact same first 5 steps as graphing a sine or cosine. All right, so step number 1. Cosecant is related to sine. Remember, sine and cosecant are reciprocal functions. And so we're going to pretend like that this equation is really -6 sine x. And we're going to graph this function as if we're graphing a sine function. So here we go. Step number 1 is the starting point. And the starting point is determined by whether you have sine or cosine. So we have sine, and sine starts at the origin. So that determines the starting point. Step number 2, phase shift. And since our value for C is 0, that means we're going to have no phase shift, okay? And remember the value for C, if you've watched any of my previous videos, C is the constant that's added or subtracted to X in the angle. So if I had, say, X plus 2 in my angle, then that 2 would be my C. But we don't have any constant added or subtracted to X. And so our value for C is 0, which means no phase shift, okay? Step number 3, wavelength. And the wavelength is the period. And for a sine or a cosine, the period formula is 2 pi over b, where b is the coefficient of x. And we can see that our coefficient of x is 1. So then the period would be 2 pi over 1, or 2 pi. And that's going to give us our wavelength. Okay, step number 4. We need 4 spaces. And the reason you need 4 spaces is because that's going to lay out your hash marks so that you can put your points in the right place, okay? 4 spaces, 4 equal spaces from start to finish. Step number 5, lay out your points. And then step number 6 normally would be connect the dots, but that's going to change because we're not really doing a sine, we're doing cosecant, okay? So now let's make our graph. So if we come down here at the bottom and get us a coordinate system, we know that we're going to start at the origin. So our very first dot is going to go at the origin. And then if I had a phase shift, I would shift it. But we don't have a phase shift. So that dot is going to stay at the origin. And then our wavelength is 2 pi. So here I'm going to start at 0, which means I'm going to finish at 2 pi. And if you're wondering, well, how far over do I go? You get to choose. You can choose how far over to make that 2 pi. I wouldn't make it too short or your wave's going to be scrunched up. And I wouldn't make it too far out because you couldn't do another period. So just somewhere in the middle there, make that a 2 pi. Remember that you always finish where you start. So if I start on the x-axis, I'm going to finish on the x-axis. And then that's going to give me a wavelength of 2 pi, which is the period. Okay? Now, I need 4 spaces. So what I need to do is I need to cut this in half, and then half the halves to give me my 4 equal spaces. And then I'm going to lay out my points. Now, the original function, notice, had a -6 as a coefficient, and that means that at the first hash mark, we need to be down here at -6. So the coefficient of your sine function tells you where to be at your first hash mark. If it was +6, I would have had a point up here. But since it's -6, it goes down here. And then we just need to continue to lay out our points. So we're going to make this bottom curve and come back up. And then we need to make the top portion of the curve and come back down. Okay? And then normally this is where you would connect the dots and make your sine wave. But this was cosecant. So that's not actually what we're going to do. What we're going to do instead is we're going to label this step number 6 for cosecant. We're going to say that on the x intercepts, those are now going to become asymptotes. So at every x-intercept, you're now going to have vertical asymptotes. And at your other points, you're going to have what I call humps and bumps. This point is going to be an upside down curve, and this point is going to be a right side up curve. Okay, I guess you could also call these stalactites and stalagmites. You got them up and down, but that's the way the curves are going to look, and that's one period. One down hump and one up hump, that's a period. And then if I need another period, I'm going to stretch this out here. And I'm going to call this over here 4 pi. Because if it takes 2 pi to make a period, another 2 pi would be 4 pi. And then I'm going to cut that up into fourths. So half it again. And then I'm going to continue my points. Okay, so we come up, down, down, up, and then up and down again. And then we make our asymptotes. Every x-intercept is an asymptote. And then you got your humps and bumps. Down hump, up hump. And there's 2 periods, okay? So that's how you're going to graph that. Now, in order to pick the right graph, you're going to have to pick the graph that has the correct scale and hump direction, I guess you could call it, okay? So we know that answer choice C is not valid because if you look at the y-axis, you can see right to the right of that is an up hump, but in our graph, we have a down hump. And so C cannot be correct. It's got the humps in the wrong places. And D cannot be correct because from 0 to 2 pi, you've only got one hump. And here, over here from 0 to 2 pi, you've got an up and a down hump. So D can't be correct. So it's either A or B. And the thing that's going to determine those answers, if you notice the boundary up here by Y, this is up at 12, where this one is up at 2. And so since my scale goes to 6, 6 and 6 would be 12, these humps are going to max out at about 12, which makes A look correct. It's got the right scale in the Y direction. And before I check, I'm going to double check with Desmos. Okay, so let's input this equation into Desmos. -6 CSC. Yes, Desmos will graph cosecant x. Enter. Wait a second. Why is it not graphing anything here? Oh, it's because I have my window set to a weird scale. If you ever type something in, you're going, where is the graph? Click this home button and it'll reset your window to a standard 10 by 10 window. Okay, so we can see here's the humps. And what I'd like to do is I'd like to reset this to be answer choice A dimensions and verify that it's correct. Okay, so -2pi, -2pi to 2pi in the x direction, and the y scale, according to answer choice A, should go from -12 to 12. And click. All right, so let's look at answer choice A. I've got a down at an up hump like so, and then a down and an up hump like so. And that's with this window setting. I guarantee you, if I set it to be -2 to 2, I won't see any humps because, -2 to 2 is going to be just in this area and there's no humps here. So I feel really good about answer choice A, especially after checking it with Desmos. Bam. All right, so now let's get the domain. And if we scroll up a little bit, the domain are the values that x can be. But notice, since we have vertical asymptotes, we're going to have some values that x can't be. Starting at 0, x can't be 0 because there's an asymptote at 0. And then if this is 2 pi, halfway back would be 1 pi. There's an asymptote. And then an asymptote at 2 pi, and at 3 pi, and at 4 pi. So if I put a 1 here, you're going to notice that there's an asymptote every integer multiple of pi. And that would be the same if I go backwards. So at -1 pi, I would expect there to be another vertical asymptote. So we're going to say the domain is the set of all x such that x cannot be integer multiples of pi, k times pi, where k is an integer. Okay, so k would be like 1, 2, 3, 4, or -1, -2, -3, -4. Any integer multiple of pi, is that an option? And that is A. Every integer multiple of pi, k is an integer. Now the range, if you go back and look at our graph, you're going to notice that there's a whole range of values in here in the middle that y cannot be. Okay? Anything from -6 to 6, there's no graph in here. It's all empty space in here. So the graph is going to exist to -infinity up to -6, and then it's going to pick up at +6 and keep going to infinity. So we need an answer choice that says anything below -6 or above +6. Okay, so that's definitely not all real numbers. Okay, this answer choice D, it says greater than or equal to -6 and less than or equal to 6. That would actually be all of the dead space. So it can't be D because there's no graph there. It can't be C because that says greater than or equal to -6. And if you look at greater than -6, again, there's dead space there. So it can't be that. So it's going to have to be A. Y can be anything less than or equal to -6 or anything greater than or equal to 6. That's where the graph is going to exist. And that's it. Man, I hope that was helpful. If you have any questions or comments, feel free to put those in the comment section below, or you can text me. And thanks for watching.